using analytics software for mission-critical applications. And this presentation is based on a paper presented at the 2012 Uptime Institute. And that is basically, it was the state-of-the-art practices for operation of critical power facilities. So we'll be discussing how you can save money using analytics software. So our panelists consist of Brent Wall. He's a Vice President, Hosting and Global Chief Information Officer at Stratec. And he's been here for 4 years. And he maintains an extensive track record of directing and developing delivery and operation of advanced technology solutions. So he's responsible for directing the operations of the Stratec data center services and managed services lines of business. And he serves as the Vice President of Information System and Services for GMAC Insurance. So he's from a Bachelor of Science in Mathematics from the University of North Carolina in Greensboro. So thank Brent Wall for being here. Our second panelist is Doug Whitmer. He's a Vice President of Sales with Power Analytics, and he has more than 20 years of executive level sales and marketing experience in critical power and data center environments. So prior to that, he was Vice President of Sales for Global Accounts Division of E. So our third panelist is Christopher Stick, and he is a specialist in utility systems planning, software, and smart grid. And he has an extensive background in utility system planning and design, operations, and protection. And our fourth panelist is Michael Haley. He is the project manager for Lake County and in charge of smart grid, IT, and software. So with that, we're going to go ahead and get started with our Paladin Live Return on Investment Overview. And this is the state-of-the-art operations for critical power facilities. Okay. And this will take approximately 45 minutes, and we will do a Q&A afterwards. So you can type the question anytime on your screen, and we will see those. And before we hit the Q&A, we'll allow you to hit *9 and raise your hand. If you have a live question, we'll be glad to accept those. So this is a series of webinars that we're developing, and it's supported with the Clean Tech cluster organizations in San Diego and Raleigh. So each webinar has a series of subject matter experts with a moderator, and we have a wide interest and audience here with different levels of expertise. So we're trying to do an overview of how you can measure ROI for mission-critical facilities. So with that, I'm going to turn it over to Doug Whitmer to start with the presentation.
Thanks, John, and welcome everyone, and appreciate you spending an hour of your time with us here, give or take. The first thing I'd like to do is kind of state or outline 2 or 3 of the more common problems and issues that we see in the mission-critical facilities world, and then as the presentation wears on, we'll relate to them how model-based analytics and some of the tools we can provide will relate and overcome these issues. The first one stated here is the issue around stranded capacity. Obviously, a very hot topic in the mission-critical world, if not the hottest topic, and one of the most talked about things on the conference scene and the trade industry groups probably for the last 18 months or so. But as you can read here, the issues are known and understood, and we'll talk to how software applications like the one proposed here can help understand and expand on this issue of stranded capacity and how we can reduce and overcome this issue. The second issue here is energy optimization. If stranded capacity is the hottest topic, then certainly energy optimization, energy efficiency, energy usage is the second hottest topic on the circuit these days. Again, we'll relate back to software, how it can benefit in these areas, and Chris here will get into some specific examples of how that's proven. Then the last topic we'll talk about has to do with maintenance. The prioritizing of maintenance, the planning of maintenance, the training of maintenance, its ramifications for the organizations, how it can hinder an organization, how it can help an organization, and the tools and how this software can help support the processes and the procedures around maintenance and eliminate some cost in that area as well. So with those three issues defined, what we want to do by the end of this presentation is relate those issues and probably a few others back to a return on investment. And these are the broad categories that we will talk to good detail on here and the dollars that can be saved by use of a model-based and model-validated software application. Energy strategies, maintenance actions we've talked about here briefly in defining the problems and prioritizing of maintenance activities. And then the increase in system capacity, as you can see, has a large number tied to that. We'll dive into that as well and show how those returns are achieved. So we'll cycle back to this in a more specific use case later in the presentation, but this will kind of set the stage for what we're looking for there. There's a payback period that shows there. The first issue we're going to talk about is the one of stranded capacity. So just kind of defining that a little bit and some parameters based on studies from EYP and Ponyman and others. This is very typical of what we see out there. Most facilities are designed and built out to somewhere in the neighborhood of 70 or 80% of the true capacity. At that point, plans are well underway or construction is underway or at least contingency plans to find the next capacity, whether it be in a co-location facility or a physical facility and a build-out of your own. We believe that with some software applications that we'll show here that you can increase this percentage and gain more value out of the existing facility. It also, the software has ramifications for both normal activity, just day-to-day operations, as well as contingency planning. So how is that capacity affected when you're on various sources of generation, i.e. diesel generators? How is that capacity affected when you're doing maintenance on certain things like UPSs and PDUs in the powertrain? So we'll show that all of that can be accounted for with the cost savings that ensue from that. The assumptions we use are built out here in a simple graph, and this will make sense, and we'll tie it to a specific use case on the next slide. But basically, we're making the assumption here that on day one of the facility, its initial occupancy capacity or its initial operating capacity is around the 60% mark. We then will show that over the period of that facility, which across the bottom axis is indicated there as 36 months, that that load will grow up and ultimately will top out at an 80% capacity. Now, the growth is probably not linear, but in some instances it would closely replicate that, so that's what we're going to show here. The third, then, you can see ultimately over the life of the facility, we're assuming that there'll be 80% of the total design capacity will actually be used for the load factor. Across the bottom axes, the build-out is planned to get to that 80% load in 36 months, and then what we would propose using the model-validated software is that you can increase that capacity up to an 85% load over the life of that facility, and by doing that, you can stretch that decision to build or to occupy another facility in upwards of 9 months in this case. So with those assumptions in mind, we'll apply this to a general use case here. And again, any ROI conversation is generic in nature unless it's using variables that are specific to your facility. So we certainly understand that, and we welcome the opportunity to talk to anybody about their specific facility. For the case of this presentation, we did base the use case on a $122 million Tier 3 data facility. Interest rates, the target loading, the maximum capacity, you can see there, all these things we discussed in the previous slides. By using our software, we could increase that capacity, or that headroom, if you will, to 85%, resulting in this 9-month delay of the build. We're going to get into how that simulation works in a minute and how that does that. I'm sorry, I skipped ahead once too many times there. But the resultant delay of the building is just a simple exercise in net present value here, and this is why this number gets so large. But based on the interest rates, so on and so forth, it's just an NPV of the money of the decision to delay that build or that move. So in the actual payback figures that you'll see in the ensuing slides, this $1.4 million was not accounted for in that. That was coming out of purely the operational savings. So as I summarize this at the end, I'll cycle back to that. But the simulation capabilities and the maintenance capabilities that Chris and Brent will talk about will further highlight this part of the presentation. With that, I'll turn it over to Chris Stick to talk about the simulation software, how it actually works, and it applies to the energy and so on from there. Thank you.
I'm going to discuss the simulation software here. Facility owners and operators have limited ability to determine what the facility energy usage should be based on the system configuration and changed load and sources. The strategies are frequently based on prior experience. Strategies are appraised by committee and tested operationally. The results of the tests are used to further refine the approach. This costs money and time. There is no prior assurance of success. In many cases, operators have limited input to energy planning. Operators have some of the most intimate knowledge of the data center. Operators lack the tools and to quantify the effects of changes to the system. So the tool that the operator can use is a tool of model-based validated analytics. And what this is it's a one line of the electrical system of this facility. So this is the Blackboard, which is a simulation environment. So this is a load flow tool where the operator can go in and run scenarios. So open some equipment, change the configuration of the system so that he can analyze what's going on. You can open breaker and switch positions on the lower panel, and we can adjust load amounts based on another panel. So then once the operator reconfigures things, adjusts loads and sources, what have you, then it runs a load flow study, and the results will come up on the side panel. So then once the study is run, a comparison can be made against the real-time numbers for the system against the simulated numbers for the system. So the top box would be the actual values that the data center sees. The bottom box is the simulated results. So then the operator can compare the two by bringing that information over to we have a calculation tool that you can take the values out of those screens, the previous screen, and enter it in and actually enter the actual amount in the top portion here. Then enter the simulated values into the lower portion here. And then find out what your cost savings are on a month-to-month and annual basis. So in this case, let's suppose the operator made some system configuration changes, adjusted some loads, what have you. That would result in this case, $18,000 a month, which comes to over $200,000 a year, just in energy savings. I'm going to hand it off to Brent Wall from StrawTech now.
So I want to cover the notion of human error. Unfortunately, I'm all too qualified to cover this, having seen a number of data center outages where human error was a factor. what I want to talk about is the notion of simulation and really how that helps to prepare for human error that will ultimately occur. Human error occurs in several different forms as manifested in the data center. First of all, it can occur because of an engineering error that happened way back whenever the data center was, when the equipment was being specified and the systems were being integrated. It can happen during the commissioning or implementation of the data center where things were not installed as planned and the testing did not materialize the error. And then finally, it can occur in the operations of the data center just in regards to not following the procedures that would yield an optimal outcome. And so the notion of having a simulation will uncover many of these things, and so that downtime that occurs in the data center can hopefully be reduced. So as you think about the simulation, there's a number of opportunities here to model what you have in the data center, and while in the notion of having a test system is very prevalent in the IT infrastructure world, it's not very practical in the data center world because of the size and expense of the gear that we are talking about. And so the only practical way to test for impending maintenance changes or for practicing for abnormal operations, et cetera, is to do it with simulation. And so I know in my fairly recent experience, several years ago, I had a situation in one of our data centers where a commissioning error manifested itself 6 years later and ultimately caused an outage in the data center because the staff in the data center didn't respond correctly to the abnormal condition. So that really encompasses a couple of the forms of human error that I talked about. There was a commissioning error that was okay, not uncovered until capacity reached a certain point, and then when capacity reached that point, it triggered that condition, and unfortunately, the staff within the data center did not respond appropriately, and an outage was created. And so, again, having the ability to go through and model your one-line cooling environment, et cetera, in a simulation environment helps to eliminate those kinds of error and ultimately gets operations staff more on their toes. So this screen is just a good view of kind of an operational view of what's happening within the data center that can be live or simulated. So the next thing I want to talk about is maintenance and the impact of the tool set as it applies to maintenance. I think that it's fair to say that many of the data centers that are in operation and that you operate today, you may or may not have been there when the thing was designed, commissioned, and ultimately have some of the history on the data center. And while many folks, many data center managers and operators really have a good command of the infrastructure and the integration within their data center, it's ultimately a problem that is larger than you can solve in your head. And so without a simulation tool, there are simply too many variables and too many ranges of operating conditions for you to consider all the possible outcomes. And so when you contemplate making a change in the environment, the ability to accurately simulate that across all of the dimensions, both the ones you know about and the ones that you don't know about, as well as across the full range of operating conditions, is really important. And so the maintenance costs in a critical environment are usually the second largest operational expense. And so the tool allows you to be able to quantify and ultimately make better maintenance decisions. And so that applies to, again, all dimensions. In other words, the various breaker topologies, various power sources, whether it be on-site generation or utility, as well as various load profiles. And so the other consideration then is that for a better planned maintenance event, there's the opportunity to get a more advantageous maintenance window. So the notion that you can only do things through your data center on Sunday morning at 2 o'clock creates lots of unneeded costs, because there's a fear factor there, having no ability to simulate what you're getting ready to do. And so if you can take some of that risk out, you may be able to save a significant amount of money in premium labor and save the disruption. So next. Yeah, I think so. In summary, just that using an analytics-based simulation gives you a lot more information. It gives you the ability to consider and to work through more permutations of operating conditions than I think the human mind has the ability to contemplate. And the net is that it can uncover things that allow you to optimize your maintenance cycles, as well as reduce costs and risk associated with them. So here's a good shot of the difference between the operations with and without simulation.
Yeah, I think this is a handoff back to me, then. This is Doug Whitmer again. What you see here, again, like Brent just said, various screenshots and so on and so forth that can show the effects of prioritizing and scheduling, and then perhaps using, I love your comment there on the maintenance window. That's really what we're trying to help out with there. If you know for certain that things aren't at risk, then you can do that in times where you're not spending premium labor, premium time, things of that nature. So just a few screenshots here to highlight how the analytics could be used and the simulation could be used, and then some of the outputs from there to do that. I think now I'll summarize back again on the ROI subjects here. And again, we're going to show relate all of these assumptions and all these things we've been talking about here, from the maintenance prioritization and the maintenance windows to the actual human training of maintenance that ultimately is trying to avoid the risk of unplanned downtime, one of the huge cost drivers there. Certainly the energy metrics and the efficiencies and the peak load avoidance and the violations that we can help avoid with the simulation and the software. So back to the case study. Again, the general assumptions were 100,000 square foot, well, not the general assumptions, this was the actual case study. 100,000 square foot facility at 5 megawatts, tier 3. The financials you've seen before, the build out was 122 million, and then there's the loading characteristics. And then the maintenance assumptions, which were tied into this that Brent just spoke to, were 75% of the maintenance activities were done on normal time and 15% at overtime. We reprioritized those activities and allowed them to reduce by 10% the premium window time that they were doing those maintenance facilities in. So the ultimate cost ramifications that came of that are shown here in this table. Now, of note is that the top line there, the stranded capacity, is a capital expenditure avoidance. So that was the large number that is based on the net present value. The other three operational savings are annual savings based in this case study, and those are the three that were used in the ROI calculation of returning a period of just over 1 year. So you can see on a facility of this size, which aren't that uncommon out there, that the savings are substantial across the energy, the maintenance, and then the downtime avoidance of human error training and things of that nature. So to summarize this this section here before I turn over to Michael, again, the 4 areas that we feel we have significant impact on, certainly stranded capacity. Again, the hot topic, one that everybody's trying to get an accurate read on, and the model-based approach that we utilize really allows us to zero in on exactly where you're at so that you know exactly where you're going and can be confident in the so-called headroom that you'd have in the facility there. The energy management costs, a huge topic, obviously dependent and vary on the geography. Power, of course, is different in Raleigh, North Carolina than it is in Boston, than it is in Los Angeles. But certainly things like peak demand avoidance, power factor violations, things like that are transcended across the globe. So we can help in mitigating, avoiding those things. The human factors on training and the improved maintenance, all 4 of those areas we feel collectively we have a significant impact on. With that, I'll turn over to Michael, who I think is going to talk a little bit about the next series and about what the Clean Tech Cluster does here and around the country.
All right. Well, thanks, Doug. And just a quick programming note, our next in the series, our next webinar in this series will be on microgrids, and that will be November 6th. So be on the lookout for information on that. It'll be another really good final in our series this year, microgrid strategies for effective cost management. So I think that'll be good for us. One of the things we talked a lot about today was data center and data center management. As many of you know from around the country, North Carolina has become a hotbed for data center location with very large enterprise facilities like Facebook and Google being sort of most prominent among those. But also here locally in the Research Triangle, we've seen large cloud computing and analytics and R&D related data centers from federal government, SAS, NetApp, and IBM being put in place. And again, companies like Stratec and Power Analytics, part of their ability to locate here is to not only work with those companies in that space, but also for the types of employees needed to figure out the tools needed for companies for these cost savings we've talked about today. One of the other things that will sort of maybe a segue into our next webinar is being around microgrids is that the Research Triangle of North Carolina, you can see on the slide the small map, the Research Triangle being made up of the 3 Tier 1 research universities, North Carolina State, Duke University, and UNC Chapel Hill. This is a global hub for smart grid innovation. When you see the companies on that list, there are very large multinationals as well as some startups in there. And it's very exciting. We're able to pull some of the best and brightest around the world to come in here and work, as well as have resources at our universities around innovation and research and development. As part of that, in 2011, the area was recognized for its concentration of clean tech and smart grid companies, and was invited to join the International Clean Tech Network. It was one of the first 10 sort of global locations, only 2 in the United States, We're asked to participate in Fort Collins, Colorado, and the research trial here in North Carolina. So it's a very exciting. So the companies that are here doing this work are certainly global leaders too, which we've heard from today.
Okay, so with that, we do have the contact information of the presenters, and this presentation will be available online, and it's being recorded. So for people who weren't able to join us today, it's going to be available online. And with that, you can type your questions or hit *9 and it'll raise your hand, and we'll be able to field any questions. And we did get a couple of questions. And the first one was, the one-line diagrams appear to have intelligence built in as far as electrical characteristics. So how is that performed?
So this is Chris. The one-line diagrams are actually the web-based interface for a load flow tool that actually runs load flow studies, where all the electrical characteristics are built into a load flow model. It's built on design-based in our case. There's several other tools out there on the market that were design-based. So it's actually load flow software that's actually running load flows and validating all the information that is on the network.
Okay, thanks, Chris. And we just got another question, and the question was, how does this technology integrated with distributed generation sources such as solar and wind?
I guess I'll jump in with that. This is Doug. The modeling software that Chris just spoke of does have the capability to bring into the power network, if you will, all of the characteristics of those devices, whether they be inverters, rotating generation sources such as wind, diesel generators, of course, fuel cells, as well as utility. All of those distributed gen or even utility gen sources can be modeled into the software. From then, it's just pulled into the graphical user interface to show the different characteristics and how they would interact with the entire power network. And then in the simulation cases, then you can also control those the same way you would any of the load sources.
Okay, perfect. All right. And another question was, in the section on human error, they wanted to know the difference between downtime. Is it really downtime, or is it human error?
Well, so it's both, and that is it's human error that ultimately leads to downtime, and of course it's the cost of downtime that ultimately creates justification for a tool set like this. As you can imagine, the cost per minute of downtime as a result of human error can rise exponentially as the minutes go by, and so it is the avoidance of that. So it's actually both.
Okay. And the actual savings here that are shown, we noticed that there was a case study, and we wanted to know how they're calculated and how can I compare them to my own facility.
Yeah, I'll jump in on that again. This is Doug, and I stated earlier, the ROI is obviously specific to one's facility and their costs of financing and capital and things of that nature. So we do have a tool that we can use to be more specific with plugging in certain variables that are specific to given sites, the tier levels, the size, of course the utility rates and things of those nature. So if someone, whoever asks the question, is interested, they can certainly contact us and we can go case by case with that ROI and really get into an interactive discussion, because things may apply, things may not apply. There may be other factors we haven't considered in this simple use case that we might be able to have some impact on. So happy to do that case by case with anyone who might be interested.
Okay. every one of these, we always get a question on how they can get a copy of this presentation, and we just got a question on how to get a copy of the series of presentations. So you can go to the STRATEC website or Power Analytics website, and they are posted online, and we will take this as a follow-up to send a note out to everyone on how to get access to this series of webinar information. So, that'll you'll be getting a notification on how to get access to that, since these are videoed and put on the web. And then the last question I'm going to take. We got a few more questions, okay? But we do have one question. Is we were talking about Blackboard or simulation, and from an electrical status for the system, what does that really mean?
So this is Chris again. The load flow tool that I mentioned earlier is actually fed with live data from the network. So the loads are read real time through the PI historian, and that data is loaded real time into the load flow software. So the load flow software is actually calculating on current real-time information on the system. What the Blackboard does is it takes a copy of that and allows for changes to be made without, so it's using real-time information, but you can change the configuration of the system or scale loads or what have you, and then calculate a simulated what would happen if these changes were happening, but using real-time data. So you can make configuration changes and compare and contrast against what's really going on in your system to what could be going on in your system, for example.
Okay, and we do have one more question, and then we'll wrap it up. It's on distributed generation and storage, and if the model can show how much energy storage is required and what the savings are associated with that.
So we can, this is Chris again, we can model storage in the software and design base, and that can be used. You can, with an experienced designer, they can use that to figure out the appropriate size batteries, and we have expertise in house that have done those studies and do those studies. And then what was the other half of the question?
How to calculate the savings.
Oh, calculate the savings. Again, the calculations that Doug had mentioned a moment ago, we have a spreadsheet that can incorporate those cost savings in conjunction with whatever your facility is already built to today. So let's suppose you have a facility or a microgrid, and you add some form of generation. We can do this. The spreadsheet that we have can do a cost estimate of the benefit of those additions to your facility, or if your facility already has that equipment, and we can model that into the same spreadsheet to estimate what the cost savings are in your energy bill and what have you.
Okay, well with that, I think we're going to wrap up our presentation for today. So we finished in about 50 minutes, so that's good. And like I said, we will follow up with how to get access to this information. And we appreciate everyone's time, including the panel, for presenting this important topic today. So everyone have a great day. Thank you very much. All right.